I'm Sapal. In this video, I will discuss to you the amides. So, amides are derivatives of carboxylic acid where the hydroxyl group or the OH group has been replaced with ammonia or amide. Amides can be classified as primary, secondary, and tertiary amides. The first classification of amides is the primary amide. Our nitrogen here is directly bonded into one carbon, and also our nitrogen is bonded into two hydrogen. So our carbon here is double bonded to one oxygen and also bonded into our group. So I will show you an example of primary amide. So our nitrogen is bonded to carbon, our carbon is double bonded to oxygen, and our nitrogen is bonded to two hydrogen. Our carbon is also bonded into our group. So let's say we will add 4 carbon atom or 4 carbon chain into our carbon. 1, 2, 3, 4. So since we add a 4 carbon atom, we will also add this carbon into our numbering. So we have a pentane. Why it is pentane? Because it has 5 carbon atoms, so it is pentane. So pentane. Ane because it belongs to alkane group. So since we have here a nitrogen or an amide, we will just cancel this E right here and add amide. So the name of this structure is pentanamide. So we will proceed to secondary amide. So our carbon is double bonded to oxygen, our carbon is also bonded to nitrogen, and also our carbon is bonded to our group. So as we can see here, our nitrogen has no R group or didn't bonded into R group. Here, our nitrogen here is bonded to one R group and also bonded to hydrogen, one hydrogen. So, for example, I will show you an example of secondary amide. So, our carbon is double bonded to oxygen, also bonded into nitrogen, and our nitrogen is bonded to hydrogen. Our hydrogen is bonded to an R group. So, let's say we have CH2, CH3. So our carbon here is also bonded into an R group. So let's say we have CH3, CH2, CH2. So our parent chain here is butane because it has a 4 carbon atoms or 4 carbon chain. So butane. Ane because it also belongs to alkane group. So our nitrogen here is bonded into R group. So our R group is ethyl because it has a 2 carbon atom. So since it is bonded to nitrogen, we will add N. So it is N-ethyl. So we will just put here or write here N-ethyl. So we will add our parent chain. So it is butane. So we will cancel the E here and add amide. N-ethyl butanamide is the name of this structure. So we will proceed to the Next, classification of amides, which is the tertiary amide. So as we can see here at our tertiary amide, our nitrogen here is bonded into 2R group, and also our carbon is bonded into one R group, which didn't change at all. So the name of this structure is N-ethyl N-methyl propanamide. I know that you may confuse why I first say or root the ethyl over the methyl, because I use the rule that is it always alphabetical, so that I first root the ethyl over the methyl, even though ethyl is higher than methyl. I will discuss to you all about lactam. Lactam is a special name of cyclic amide. Lactam is a cycle structure. Cyclic is a closed carbon chain or a ring. So, I will show you an example of a lactam. This is an example of a cyclic structure or a ring. So the first thing we must do in order to name this structure is to name our carbon atoms here. So our first carbon is alpha. Our second carbon is beta. So the name of this structure is beta lactam. So we will proceed into another example. As you can see, this structure is also cyclic. So the first thing we will do is to name the first carbon, that is alpha. The second one is beta. The third one is gamma. So the name of this structure is gamma lactam. So we will proceed to our third example. So this structure is also cyclic, so we will just name our carbon atom. So here we have here alpha, beta, the third one is gamma, the fourth one is delta. So the name of this compound is delta lactam.
Hello, I'm here again to discuss thioester. So, thioester are compounds with the functional group So, they are analogous to carboxylate esters, with the sulfur in the thioester playing the role of the linking oxygen in the carboxylate ester. So, the general formula of thioester is like this. Group So, sulfur represent for thio means sulfur, or this sulfur represents for thioester, or thio means sulfur. Thioesters are product of esterification between carboxylic acid and a thiol. So the IUPAC suffix of thioester is thioate. And the IUPAC prefix of thioester is OAte. So I will give an example of thioester compound. So here we go. So how can we name this compound? So we have here a methyl. So since we have only one carbon here, we will name this as methane. Ane because it belongs to alkane group. So the IUPAC name of this compound is methane thioate. So the common name of this compound is methyl thioformate. Now another example, I will give another example. So we go CH3 bonded to carbon, then carbon is double bonded to oxygen, carbon is bonded to sulfur, CH2 CH3. So how can we name this compound? Simply so we have here a ethyl, and since there are two carbon, we will name this as ethane. Ane because it also belongs to alkene group. So the IUPAC name of this compound is ethyl ethane thioate. And the common name of this compound is ethyl thioacetate. So that's all. Thank you. Also, thioesters are more reactive than esters, and the thiol group is easily replaced.
Hello, I'm here to discuss the acid halide. So, this acid halide is also a derivative of carboxylic acid. The functional group of an acyl halide or acid halide is an acyl group bonded to a halogen atom. So, the examples of halogen atoms are bromine, fluorine, chlorine, and etc. So here we have a carboxylic acid here. So we will name this. We will number our carbon atom. So 1 and 2. So we have 2. So this is ethane. Ane because it belongs to alkene group. So since it is an carboxylic acid, we will remove this E right here and add oic acid. So ethanoic acid. So the common name of ethanoic acid is ethanoic chloride. Ethanoic chloride if we derive this ethanoic acid into an acid halide. So the next examples we have here is this. We have here a cyclo or a ring. This ring is pentane. So since this is a cyclo or a ring, we will write here cyclo. So this ring is pentane, we will just add here a pentane. So since this is an example of carboxylic acid, we will add here a carboxylic acid. So cyclopentane carboxylic acid. So if we derive this cyclopentane carboxylic acid into acyl halide, this will become cyclopentane carbonyl fluoride. Remember, when we place the E with simply oic acid, but this is an acyl halide and the same name is derived from the carboxylic acid name. Hello, I will discuss to you acid anhydride. So, acid anhydride is also one of the derivatives of carboxylic acid. A functional group characterized by two acyl group joined by oxygen atom. So, the names of acid anhydride is derived from the actual original carboxylic acid. This is carboxylic acid. This is also an carboxylic acid. The name of this is ethanoic acid. This is also ethanoic acid. Okay, so if I were combined these two carboxylic acid and at the same time take out water, there it is two hydrogen and an oxygen, and combine them together and will look like this. As you can see, this is a symmetrical anhydride. The name of this structure is ethanoic anhydride. This is an example of an anhydride. So the common name of ethanoic anhydride is acetic anhydride. So what if I will add here another carbon atom? So basically it will become mix anhydride or unsymmetrical anhydride. So the name of this structure is also the name of this structure is, first we will name this side. So we will just count the carbon atoms. So 1, 2. So this is ethane or ethanoic. Here we have here a 1, 2, 3. So 3 is equivalent of propane or propanoic. In naming, we will first write the E because of the alphabetical rule. So we will write here ethanoic. Next one is this propanoic. And since this is an example of an anhydride, we will just add here anhydride. So the common name of ethanoic, propanoic, anhydride is acetic propanoic anhydride.